Advantage of the Earth's natural spin to help accelerate away from Earth's gravity, possibility of creating a tunnel. But this is very much pie in the sky for now. Musk's near-term
It's 2021 and we still have to haul our trash cans to the curb. It's time we do something better, something smarter, like CMOT, our automated trash can project.
Controlled by a phone app, CMOT runs on a schedule, going out to the curb exactly when you need it to, and coming right back in when it needs to. Whether it's pavement or grass, CMOT has you covered.
Hi there, Ernie here and welcome to Sesame Street. Here's James with the stop motion camera slider.
Thank you, Ernie. Our camera slider is designed to simplify the creation of moving camera shots in stop-motion animation. Our user interface allows the animator to simply input the desired frame rate and speed, and the program will calculate the appropriate distance between frames. Once that's set, simply press take frame forward or backwards and you're on your way animating.
Hey, what if I show some shots I made?
That's a great idea, Ernie.
Here's a tracking shot. A nice dolly zoom. How about some special effects? Even a time lapse.
Those look impressive.
Thank you, James, and thank you for watching, everyone. We couldn't have done this without viewers like you. Goodbye.
Hi, my name is David Rodriguez, and this is on the Hazmat Reconnaissance Robot Project. The purpose of this project is to create a device equipped with cameras and sensors for a hazmat operative to be able to remotely assess a hazmat situation. We were able to integrate the motors, the logical circuit, the batteries, and the tires onto the chassis and demonstrate a drivable robot. The next portion has to do with the sensors that will be added onto the chassis. The 6 that we've already integrated include ammonia, hydrogen sulfate, carbon monoxide, carbon dioxide, methane, and one sensor that combines propane and butane. These 6 sensors have already been integrated on our online graphical user interface on Adafruit and can be demonstrated that they work in real time. The last portion of the project has to do with the cameras that will be mounted on the robot. There will be 5 in total interacting with the online graphical user interface.
Hello everyone, Team 25 here, and this is our project, the Hero Drone. The project consisted of building a catamaran-style hull along with a mold for reproduction. Its purpose is to conduct water research autonomously, and inside the case we're going to show you the electronics, which the purpose is for navigation and data research for the NSF. Here is Mission Planner. In this software, we can plan missions through various waypoints. As you can see, we are sending the information to Pixhawk to conduct the navigation in auto mode.
This is our hydrogen fuel cell characterization station. There are many variables which affect the performance in the fuel cell. Here we have the mass flow controllers to control the gas flow into the system, the bubblers to humidify the dry gas, the thermal jackets to increase the temperature of the gas flowing into the system, the thermocouple to monitor the temperature of the fuel cell, and the 15 psi check valves to control the back pressure of the system. Using the Auto Lab, we collect the data for our analysis. In 5 different experiments using different humidity levels, back pressure, temperature, and flow rate, we compared the cyclic voltammetry, the chronoamperometry in the form of a polarization curve, and the electrochemical impedance spectroscopy.
Passion flower.
Welcome! Our team Numblu will present the autonomous dry vacuum cleaner for enriched uranium. This device will map the area in real time for obstacle avoidance and autonomous navigation. Furthermore, it has a motor that is capable of collecting dense materials such as enriched uranium. We aim to collect enriched uranium dust for safer work environments in nuclear facilities.
With the lidar mounted in the middle of the body and utilizing a SLAM package, we successfully create a map of the environment while simultaneously remembering where we have been. We made sure the device can pick up tungsten powder by leveraging the power of a Dyson outsized vacuum. Since tungsten has a slighter, higher density than uranium, this proves we can successfully pick up uranium in its powdered form.
The Radioactive Uranium Monitor, or RUM, is a sensor networking that will be able to detect the levels of radioactive material on a specific location and alert the user when the levels are too high. The following video will explain its current capabilities.
The Node MCU will read data off the sensors and push it onto a database. Then the database will push data onto the website. As we can see here, our first view is a login page with a username and password, and we can log in and see the dashboard view, a list view. We can filter our sensors by name, by its reading, by its status, whether it's online or offline, as well as the location of each of the sensors. The RUM also has an alerts tab, where high readings and sensor malfunctions are displayed. They can be filtered out by date so the facility can better understand which procedures cause high readings. The alerts are classified as informative, warning, error, and critical. The RUM also has the capability of deleting notifications when desired. And lastly, we can log out.
We have known for many years that electric cars can only be charged to power cables. We have an example over here on a charging station at our school. Our team has found a way that can revolutionate this way of charging to do wireless charging, which is This is our period car. We have implemented the wireless electrical charger in our golf cart. We have the primary power supply that will transfer electricity to the primary coupler and later to the secondary coupler, where it will be converted and later charging the batteries of the car.
Once you leave your car at the charging station, you will be able to check through your Android device how the battery charges, the status of the voltage, current, power, total consumption, and cost.
Hello everyone, my name is Itai Firan, and this is our project, Smart Farm. Smart Farm is a fully automatic, indoor hydroponic planter that comes to solve the problem of having fresh herbs for your cooking needs. What makes Smart Farm smart is its app control, where sensors are logging the information, sending it to the cloud, and then back into the app. Over here you can monitor the vitals of the ambient surrounding, turn the lights on and off, and the user can also set their time zone so that we can set the scheduling of the lights. The light spectrum are set to the red and the blue wavelength for optimal plant growth. Hydroponic means that the roots are suspended in the water tank. Smart Farm is also equipped with a water valve solenoid so that you can connect it to an external water source similar to a refrigerator so that you don't have to fill the water every once in a while. The Smart Farm also has a few additional sensors such as a float sensor to sense the height of the water and has an air pump to oxygenate the water for the roots.